Imagine describing a world just from your imagination and then watching it come to life right in front of you as a full-blown video. This isn't some far-off sci-fi concept anymore. This is happening right now. And it's both the power and the puzzle of generative AI. Just listen to the language here. It's not just a woman walks in Tokyo. No, it's stylish, the street is damp and reflective, creating a mirror effect. These aren't just words you see. They're instructions for creating a whole vibe, a mood. And that's the giant leap we've taken, from simple commands to complex, almost cinematic world building, all from a text prompt. So this brings up two massive questions. First, on a technical level, how on earth does a machine actually do this? How does it turn those words into a video that looks and feels real? And second, the bigger picture. As this tech gets better and better, what does it mean for creativity, for what we consider truth, and for reality itself? Let's dive in and break it down. Okay, first up, the evolution of AI video. How did we get here so fast? I mean, going from clunky, still images to entire moving worlds feels like it happened overnight. The pace of change here is just staggering. If you look back to the late 2010s, models could barely stitch a few frames together. Then, in the early 2020s, we got diffusion models, which brought a new level of realism. Single moments started to look almost photorealistic. But the real breakthrough, the one that started in 2023, is the space-time transformer. That's the engine behind models like Sora that lets them create these longer, more coherent scenes. So how do these space-time transformers actually work? Well, a simple way to think about it is that they see video by breaking it down into tiny chunks, or patches, both in space, like a piece of the image, and across time, like a single frame. It's kind of like how a language model breaks a sentence into individual words or tokens. By analyzing these patches in sequence, the AI starts to learn the grammar of motion. It understands not just what an object is, but where it's probably going next. And here's the thing about AI development. You solve one problem and a whole new, more complex one pops up. With the last generation of models, the big challenge was just making things look real. Now with these new space-time models, the problem is logic. Can the AI keep a character's shirt the same color for a whole minute? Or can it prevent a random cat from just poof appearing out of nowhere halfway through a shot? That's the new frontier. Okay, section 2. Sora versus the competition. Sora got all the headlines, yeah? But it is far from the only game in town. This field is getting really crowded, really fast. So this chart tells a really fascinating story. You'll notice that Google's VO2 is really pushing for length and resolution. We're talking up to 2 minutes at 4K. But then you look over at Kling and Runway, and they're focused on creative control, offering things like camera adjustments and lip syncing that Sora doesn't have yet. It's that classic trade-off, right? Do you want a longer, higher res clip, or do you want more hands-on control over a shorter one? But for all their incredible power, these models are still kinda weird. And users are discovering that when the AI gets something wrong, it gets it wrong in ways that are just, well, they're truly bizarre and honestly pretty hilarious. I mean, you really can't make this stuff up. This comment from a Reddit user just perfectly captures the strange paradox of AI video. It can generate something absolutely stunning one moment, and then this. These little quirks are the perfect reminder that the AI doesn't understand what a body is. It's just predicting the most likely next pixel, even if that prediction results in some anatomical nonsense. So when you look at the expert reviews, the verdict isn't really about which tool is the best. It's more about who is this for? You've got artistic tools like Runway, great for lighting. You've got action-focused ones like Kling. And then Adobe's coming in from a totally different angle with Firefly, which is built on commercially safe data. That makes it the go-to for businesses that are trying to steer clear of copyright trouble. All right, part 3, cracking the prompt. Because, the most powerful feature of any of these tools is you. Let's get into the art of actually talking to an AI. This right here, this is the fundamental rule for anyone getting into this stuff. You're not just a user pushing a button. You're more like a collaborator. Honestly, your ability to write a great prompt is what separates a glitchy, generic clip from something that feels truly cinematic. Okay, so how do you write a great prompt? Well, it really boils down to these principles, but they all share one big idea. You've got to think like a film director. Be super specific, structure your scene with a beginning, middle, and end, add sensory details, call out your camera shots, and then, this one's critical, iterate. Your first take is almost never your best one. Let's make this real with an example. A basic prompt is a red fox running through a snowy forest. Okay, fine. But the improved prompt sounds more like this. A red fox with a bushy tail runs through a dense winter forest. Morning sunlight filters through the branches. Wide-angle shot, gradually transitioning to a close-up. You hear that difference? It's night and day. You're giving the AI sensory details and camera direction, a whole scene to build. And hey, knowing what not to do is just as important. The AI has no idea what beautiful means. You have to describe why something is beautiful. You have to avoid contradictions, like asking for a sunny day with a starry night sky. And don't try to cram an entire movie into one prompt. Just keep it focused, keep it logical. Okay, moving on to section 4, the unseen costs and risks. Because believe it or not, every single time you click that generate button, there's a cost that goes way beyond your subscription fee. There's a massive, almost invisible physical cost. So when you hear this warning from Elon Musk, he's not talking about the little chips inside your computer. Nope. He's talking about the huge electrical transformers on our actual power grid. The demand for electricity to train and run these massive AI models is getting so big, it's starting to strain the very infrastructure that keeps our lights on. And it's not just about electricity, it's also about water. A lot of water. So look here. The first hit is what's called Scope 1 water. That's used right there on site at the data center, mostly for cooling towers to keep the servers from melting. But then there's the second hidden hit, Scope 2. That's all the water that the power plant needs to use just to generate the electricity that the data center is demanding. It's a huge two-part environmental price tag. But, beyond the environmental stuff, there's an even bigger, maybe even scarier question. If anyone can generate a totally realistic video of, well, anything, how do we ever know what's real again? What happens to the very idea of trust? Look, this tech just opens up a total ethical minefield. The one everyone thinks about, of course, is deepfakes and misinformation. But underneath that are these deeper questions about intellectual property. Was your art or photo used in the training data? What about the biases that get baked into the models, or the potential for political manipulation? This is exactly why reliable watermarking, a way to trace a video back to its AI origin, isn't just a nice-to-have. It's becoming an absolute necessity. All right, for our final section, let's zoom all the way out. Because for the people creating this stuff, AI video isn't even the final goal. It's actually a stepping stone towards something way, way more ambitious. Building a world simulator. This right here, this is the end game. OpenAI flat out calls Sora a world simulator. The thinking is, to generate a truly realistic video, an AI has to implicitly learn the basic rules of physics, how gravity works, how light bounces off things. So the goal isn't just about making cool movies, it's about building a model that can actually simulate reality itself. And that is seen as a major step toward what they call artificial general intelligence, or AGI. And that leaves us with one last, pretty profound thought to chew on. These tools started out just by mimicking our world, but as they get better and better at actually simulating our world and creating new realities that are indistinguishable from our own, how will it end up changing our perception of reality itself?